A recent announcement from NASA's leading astrophysicists has sent shock waves through the scientific community. Betelgeuse, the colossal red supergiant star, is showing signs of unprecedented instability that could lead to its catastrophic demise at any moment. For years, astronomers have speculated about when this celestial giant might go supernova, but now the James Webb Space Telescope has captured data suggesting that the event could be imminent. Here's why this matters. Betelgeuse is so massive and close to Earth that its explosion will be visible even during daylight, and its effects could ripple through our solar system in ways we're only beginning to understand. More unsettling, the latest images from the JWST reveal unusual infrared signatures, heat surges, and mass ejections indicating an acceleration in the star's life cycle. Imagine the night sky permanently altered, with constellations fractured and the possibility of cosmic debris spreading closer to our region of space. Are we prepared for the aftermath? And why does NASA appear more focused than ever on Betelgeuse? As speculation grows, one thing is certain. If Betelgeuse goes supernova in our lifetime, it could redefine humanity's understanding of the universe and our place within it. Betelgeuse, one of the brightest and most massive stars in the night sky, is nearing the end of its life, and its eventual explosion as a supernova is expected to rewrite the rules of astronomy. What makes this even more extraordinary is the possibility of an asymmetrical explosion, where an immense burst of energy and matter could be ejected unevenly, creating shockwaves capable of reaching neighboring star systems. Recent data from the James Webb Telescope and NASA's Chandra X-ray Observatory suggests that Betelgeuse has undergone an unusually large surface mass ejection (SMME), a phenomenon never observed at this scale in a red supergiant. This SMME released more than 1 billion times the energy of a solar flare, and its trajectory suggests an alarming potential. An intense burst of plasma and radiation could target surrounding star systems. Such a scenario raises urgent questions. Could this wave disrupt the delicate balance of gravitational forces within our galaxy? Might nearby systems, including those with habitable zones, experience catastrophic consequences such as destabilized orbits or increased radiation exposure? These are not idle speculations but pressing concerns, driving NASA's renewed focus on Betelgeuse's behavior. Adding to the intrigue, simulations indicate that if Betelgeuse does explode asymmetrically, the debris field could expand unevenly, creating dense pockets of interstellar material. These regions might collide with other celestial bodies or even interfere with critical space exploration missions in the coming decades. What's perhaps most concerning is that no one knows precisely when this event will occur. The buildup of unpredictable energy surges hints at a ticking time bomb, but how close are we to detonation? And if it happens sooner than expected, what secrets might the explosion reveal that we aren't prepared for? NASA's James Webb Space Telescope is not just observing Betelgeuse. It's rewriting the playbook on how we study dying stars. What makes NASA uniquely positioned to tackle this potential cosmic event is the combination of cutting-edge infrared capabilities and access to collaborative global expertise. This positions Webb as the only tool capable of detecting subtle changes that could signal the star's imminent explosion. Webb's ability to capture infrared radiation from deep space allows it to peer through the gas and dust clouds surrounding Betelgeuse. Recent readings have revealed sharp spikes in energy levels and unpredictable material outbursts from the star's core. This level of precision is something that traditional telescopes, including the Hubble, simply cannot achieve. NASA is leveraging Webb's data to build predictive models, aiming to correlate the surface mass ejections with the final stages of a supernova's life cycle. If successful, this would be the first time in history that astronomers could predict a star's collapse with accuracy. Betelgeuse's explosion, though millions of light-years away, carries potential risks to satellite technology and space exploration. NASA is actively coordinating with the European Space Agency, ESA, and other organizations to create contingency plans for managing increased radiation and potential interference with Earth's orbiting satellites. The joint effort is critical because, without these measures, a sudden supernova could jeopardize everything from Webb's advanced spectrography capabilities to global communication networks. Webb's advanced capabilities allow it to measure the elemental compositions in Betelgeuse's ejections, providing a real-time view of the star's instability and helping identify warning signs missed by traditional optical telescopes. This technology, combined with NASA's Deep Space Network, gives scientists a 360-degree perspective of the evolving phenomenon. If NASA's models fail, humanity risks missing the first real opportunity to witness and study a supernova in its early stages, a loss that could set back our understanding of stellar evolution by decades. Even with Webb's advancements, astronomers acknowledge that the unpredictable nature of stars like Betelgeuse leaves room for error, and the timeline for such an event remains speculative. Recent simulations grounded in cutting-edge findings from the James Webb Space Telescope reveal that the star's eventual explosion as a supernova could have cascading effects reaching far beyond the stars. Experts warn that the radiation from such an event could trigger magnetic storms on Earth, disrupting critical technologies like satellites, power grids, and communication systems. Astronomers predict that when Betelgeuse explodes, the burst of high-energy radiation and cosmic debris could alter Earth's magnetosphere temporarily, resulting in geomagnetic storms similar to, but potentially stronger than, those caused by solar flares. For industries dependent on satellite communications, think GPS navigation, weather forecasting, and global internet networks, the fallout could result in temporary blackouts or degraded service worldwide. More unsettling is the potential risk to power grids. A supernova-induced geomagnetic storm could overload transformers and cause widespread outages, particularly in regions already vulnerable to such disruptions. If Betelgeuse's explosion occurs unexpectedly, the lack of preparation could leave infrastructure systems exposed to potentially catastrophic consequences. NASA and ESA are already exploring preemptive strategies using predictive data from the James Webb Telescope. Agencies are developing advanced alert systems designed to monitor radiation surges in real time. ESA has proposed adding dedicated stellar burst shields to future satellites, technology that could protect essential orbital systems from sudden spikes in cosmic radiation. Meanwhile, partnerships with private companies like SpaceX are paving the way for adaptive satellite constellations capable of automatically adjusting orbits to avoid radiation-heavy zones. This alliance between public and private sectors demonstrates how space exploration challenges are reshaping global technology strategies. On the other hand, the insights gained from observing Betelgeuse's explosion could redefine how we prepare for and respond to cosmic events. By studying the elements formed during the supernova, scientists could unlock new understandings of how the universe creates heavy metals like gold and uranium, resources essential to advanced technology. Additionally, this event may provide key data to help develop future interstellar travel methods, including shielding spacecraft from radiation in deep space. If efforts to monitor Betelgeuse falter, the consequences could ripple through decades of space exploration. Missing crucial warning signs may delay critical technological advancements and leave Earth vulnerable to unforeseen cosmic impacts. Even with current technology, experts admit gaps in our understanding, raising the stakes of what happens next. Betelgeuse's fate is more than a scientific curiosity. It's a test of humanity's readiness to navigate the unknown. Could the supernova reveal secrets that elevate us to the next stage of space exploration? Or will it expose vulnerabilities that set us back? Failure to accurately monitor Betelgeuse could result in missed opportunities to prepare for its potential disruptive effects. If the supernova triggers unforeseen magnetic storms, power grids worldwide could collapse, plunging cities into darkness and crippling modern infrastructure. Satellite networks that sustain global communications, navigation, and emergency response systems could be disabled, leaving billions without access to vital services. In a worst-case scenario, Earth's magnetosphere could briefly weaken, exposing our atmosphere to higher levels of cosmic radiation. While unlikely to cause direct harm to life, this could accelerate the degradation of satellites and impact future space exploration efforts. The disruption wouldn't just be felt today. It would set back progress in ways that could take decades to recover. If Betelgeuse's explosion allows astronomers to unlock the secrets of element formation, such as gold and uranium, new technologies could arise, technologies with dual-use potential. Imagine advancements in energy production or material science that revolutionize industries. But alongside these breakthroughs come questions. Who controls these discoveries? Could they exacerbate inequality or even be weaponized in geopolitical conflicts? Moreover, the sudden abundance of data from this event might overwhelm existing scientific frameworks, leading to disputes over ownership, interpretation, and the ethical use of knowledge. What happens if one nation or organization monopolizes insights from the supernova? These are not hypothetical concerns. They are looming realities. The success of missions like those led by NASA and ESA could redefine our place in the cosmos. By perfecting supernova monitoring, humanity could lay the groundwork for interstellar navigation systems, shielded spacecraft, and even the identification of habitable exoplanets. However, failure to act decisively risks cementing Earth's isolation, tethering us to a single, fragile planet vulnerable to both cosmic and terrestrial threats. Perhaps the most intriguing aspect of Betelgeuse's instability is the unexpected new temperature readings and chemical fingerprints in the gas surrounding the star. These suggest phenomena that current models cannot explain. Could these anomalies hint at entirely new physics or even forces shaping the universe that we've yet to comprehend? The stakes couldn't be higher. If Betelgeuse defies expectations, it may challenge everything we think we know about star death and the fabric of the cosmos itself. The question remains, are we ready for what comes next? Astronomers worldwide are grappling with the implications of Betelgeuse's increasing instability, and opinions are divided on what comes next. New data from the James Webb Space Telescope and other observatories suggest the star may be closer to a supernova than previously thought, with some experts predicting the event could occur within the next few decades or sooner. But what does this mean for humanity and our understanding of the universe? Recent findings have prompted NASA to issue updated models estimating a 50% likelihood of Betelgeuse's explosion occurring within the next 100,000 years, a short window in cosmic terms. Some astrophysicists, such as Dr. Emily Levesque from the University of Washington, argue that the erratic dimming cycles and unprecedented material ejections indicate a much shorter timeline. Dr. Levesque highlighted a specific anomaly, a sharp decline in Betelgeuse's brightness in 2019, which data now links to a massive surface mass ejection ejecting over 400 billion times the mass typically seen in solar flares. If Betelgeuse does go supernova within the next few decades, it would be a once-in-a-lifetime opportunity for astronomers to study the mechanics of star death in real time. Observing the event could provide direct evidence of how elements like gold and uranium form during stellar explosions and help refine models of black hole formation. If Betelgeuse collapses beyond a neutron star threshold, it could lead to groundbreaking discoveries about the structure of the universe, including previously unobserved phenomena like asymmetrical explosions. Furthermore, the supernova would illuminate the sky for weeks, creating an unprecedented chance to engage public interest in astronomy. On the other hand, experts warn of unintended risks. A large enough explosion could release high-energy radiation capable of temporarily affecting Earth's magnetosphere. While unlikely to cause direct harm to life, such an event could trigger geomagnetic storms that disrupt satellite communications, power grids, and navigation systems. There is also a risk to astronauts aboard the International Space Station or future space missions, as debris clouds could be introduced into space, potentially threatening orbiting satellites and future launches. Dr. Brian Meir from Columbia University cautions that our reliance on space-based infrastructure could magnify these risks, likening the potential fallout to a cosmic domino effect. A supernova of this scale may also raise unexpected ethical and philosophical questions. For instance, could nations use newly discovered materials or technologies for competitive advantage, widening global inequality? Might the study of black hole formation challenge existing physics, forcing a redefinition of fundamental scientific laws? Could observing this event spark debates about our preparedness for larger cosmic threats such as gamma-ray bursts? Additionally, if Betelgeuse's explosion deviates from current models, e.g., forming a black hole instead of a neutron star, it could upend long-held theories about the life cycle of massive stars, leading to what some call a paradigm shift in astronomy. As astronomers continue to refine their predictions, one critical question lingers. Could Betelgeuse's explosion reveal unknown forces at play in stellar evolution? While the data suggests a ticking clock, the exact timing and nature of the event remain shrouded in mystery. What happens next will not only shape our understanding of Betelgeuse but also redefine humanity's role as observers of the cosmos. The countdown to BJ's explosion continues, with scientists warning that its supernova could leave an indelible mark on humanity's view of the cosmos. However, The true scope of its impact remains shrouded in mystery, keeping astronomers and the rest of us on edge. If Betelgeuse explodes, the night sky could change forever. Some simulations suggest that the supernova's brightness could rival that of the full moon, casting shadows on Earth and remaining visible during the day for weeks or even months. Imagine a second moon dominating the sky, disrupting the familiar constellations that have guided humanity for millennia. This transformation would not only alter astronomy but also ripple through cultures and communities, sparking myths and stories in a way unseen since ancient times. What scientists don't know is just as intriguing. Could the explosion trigger a chain reaction of cosmic debris? What if the event reveals unknown forces at play in the universe, challenging long-held models of stellar physics? And how would Earth's space infrastructure cope with the potential fallout of a supernova this close? Adding to the suspense, some experts believe that Betelgeuse's erratic behavior hints at phenomena we've never observed before in massive stars. Could its explosion defy expectations, producing effects that stretch far beyond our current understanding? While the uncertainties are staggering, scientists have not been idle. Advanced monitoring by the James Webb Space Telescope and other observatories is providing new clues. Temperature fluctuations and material ejections suggest that Betelgeuse is shedding its outer layers at an accelerating rate, potentially signaling the star's final stages. This means we may be closer than ever to uncovering the secrets of supernovae and the formation of black holes. NASA and international teams are developing predictive models to estimate the explosion's timing more accurately. If successful, this would be the first time humanity has watched a supernova unfold with forewarning, allowing scientists to collect unparalleled data in real time. The potential breakthroughs come with challenges. Astronomers are racing to prepare observatories worldwide to capture the event, but competition for resources and time constraints could leave critical gaps in our understanding. Meanwhile, questions remain about how to protect satellites and communication networks from potential geomagnetic disruptions caused by the supernova's radiation. Will we rise to meet the challenge, or will the explosion catch us unprepared, exposing vulnerabilities in our technological infrastructure? Is Betelgeuse about to explode, or will it defy all expectations? The next revelation could change everything we know about the universe and our place in it.